Hello, everyone. This is a small meeting uh, on BlueStore uh, for Tenctacle, what goals we intend to have. As you guys know, BlueStore is mostly in an upkeep phase, which is reflected with a weekly Tuesday meeting that's named BlueStore Upkeep and Evolution in that order. But it does not exclude that we have still a lot of work. Um, for Tenctacle, the focus will be uh, to combat various types of performance degradation we observe on longer running clusters. So, uh, first item we created to address it. Perry created a scraper tool. That's a simple, not so simple, but basic on existing admin socket command dump historic ops tool that queries running OSDs and captures OSD operations to a very, very long log. And that part is mostly done. I mean, it's working. Matt van der Meulen from DigitalOcean has already used the tool successfully on their cluster, and we got initial sample of four logs, about 80 million operations each. That gives us some ability to play more with the tool and improve it, and also to adapt for using the ops in a useful way. So we will be trying to address community to get even more logs. But first, we would like to provide some results that we really can benefit from having them, that it's not just us wanting more and more. So we very recently created a very simple replayer for those scraper logs, and it's been tested. It really shows that significant discrepancies between how we are testing our software on FIO, whatever random workload we do, and what we get from those logs. And that's the basis for our work on Tenctacle. We will try to add in as many places as possible to adapt for the kind of workloads we get, the real life workloads. That's it. For now, we still have to do few more steps because we're grabbing ops from OSD level, and that is a bit of problem because for replicated pools, only those make sense really for now, for us. And we see write ops only when they go directly to primary, but we also have some replication ops that we do not see a content, and we cannot reproduce them. So we need extend that replayer or create a mixer that will factor out the fact that we have usually many more reads than writes for a particular OSD. And still, it turned out that 80 million ops is not enough to fill out an OSD, and we would need to create overlapping patterns to basically fill, for example, 1 TB of single OSD storage. The small task that stems from that scraper also is RBD fragmentation check, because the workloads we got from DigitalOcean are obviously RBD, and we can see that there are specific patterns that we get we did not expect. We often addressed the problems that not really happen in real life. Uh, that work is ongoing, and I will maybe share some results on Cephalocon this year to dispel some myths about specifically object fragmentation and its role in a cluster, in RBD degradation, in OSDs that run mostly RBD. Very quickly, we also want to make some visual hint to represent fragmentation, if that happens to be really the factor that is relevant um, for OSD quality, for performance degradation. For a long time, we thought that it is, and it might happen that it's not. If it will still be a good predictor of a performance degradation, we couldn't find any other, we will try to make something more um, something carrying more information than just a single number. We would prefer to have a single number, but maybe some histogram or graph density representation would be better for an operator to just take a look and ascertain quality. Maybe that wouldn't be even fragmentation. Maybe that would be a report on allocator stats or fragmented reads from OSD, something. We don't know yet. That fragmentation visualizer is here because we thought that this will be something we will do. Next point. In any case, we have single point in BlueStore, that is KV-sync thread, which usually is not fully loaded, but still any latency that we have in that thread directly corresponds to op latency, write op latency. So we created for now one modification, which is basically done. Pere created a wrapper around write ahead log, original RocksDB write ahead log, that gets us to do just single fdata sync on a target device instead of two. So we're directly cutting latency, but there are more possible improvements. Still, even if we have only one writer to the device, the next step after writing data to the device is sorting key values into mem tables. And that can take a long of time. It's not really visible if we're testing RBD, but if we're having a lot of OMAPs, then sorting those keys into mem tables can take significant amount of time. Hence, the research we will do on trying to utilize a pipeline feature in RocksDB. That should give us ability to have more than one thread to sort keys into memtable. Then we have project that Igor Fedotov has been working for some time, but we still have to see the results. It's providing a custom write-ahead lock. We will completely bypass limitations of the kvsync thread and just exploit the parallelism of writing to the file and sorting the keys. It might happen, it might be successful or not. Next large topic, that recompression is a thing that we want. It's basically an improvement over existing compression we have in BlueStore. It's just allows to select between how much CPU we want, CPU or compressor resources we want to put to it, or how much we want to get a data compressed. So you have to either select do a lot of processing but squeeze data a lot, even if you have to read adjointed regions and recompress them together, or be a conservative, just do minimal additional data shuffling. That thing showed a very significant benefit, but I'm afraid it might not stand up to scrutiny after we do extensive testing with RBD, actual RBD workloads that we scraped, that I talked before. It worked very nicely on FIO random writes and then random reads. That was working very good. But we will see. And important part of that task is we have to find that optimal setting. As I know from initial tests, there are some settings that with additional CPU usage, I'm not really getting any additional size benefits. And contrary, on some lower settings, I can just minimally bump up CPU usage to get much better results. The next thing is ongoing. That's an excellent proposal from new BlueStore contributor, Gary Drankovic. The most amazing thing in that PR is that it showed a way how to modify objects or that are all nodes that are already in BlueStore during a read operation. I guess it requires some testing, maybe special PR just to test it, but the concept looks valid. And the usage here is to hijack on scrub operation and do complexive defragment or recompress just during a deep scrub, as we just read the data, and with minimal extra effort, we are able to benefit from it, just recompress or write somewhere else in a defragmented manner. Of course, that's like very good for operating on cold objects, but it seems like we would also like to have something like that for hot objects. We have, as usual, ongoing work on providing best allocators. We have a very good work from Igor. It's significantly a new dimension to allocators in this one, because it, in addition to having a better mm, memory organization in main allocator part, it provides non-locking queue to reuse last released disk extents. So that should address very nicely problems we had in some deployments, that due to high fragmentation, allocator took a lot of time to process allocations. So I'm very happy we could finally merge that. But it might not be the end of the line with disk allocators. I just by manual inspection, it's not that I made significant analysis on the data set, but from manual inspection of RBD workloads I got, it looks like we could have some predictors that will significantly improve the data consistency and object localization when doing overrides. So I'm hopeful for creating even new allocators just dedicated and or tuned for RBD OSDs. OSDs by backing RBD pools. Next topic. We know that typical deployment on single drive, or like on if customers do have one NVMe drive, they just want to put both BlueStore and BlueFS directly on one device and let BlueStore decide how it should organize its space. Unfortunately, it's like we were not up to the task, and when we're mixing BlueStore allocations and BlueFS allocations, they change in a completely different patterns and are released in unpredictable ways with relation to each other. Mm, that pattern is not very good in a long term. So there is, I have idea to make an experiment how much we would possibly benefit if we recommend splitting creating partitions in single device, even if both of those parts will be used for the same OSD. It's just experiment. The results in ideal world, it should be that BlueStore and BlueFS should be able to cooperate nicely with each other. And we had that solution very early in Luminous, that we were gifting a space between BlueFS and main BlueStore, but it had so many other limitations that we finally converged into basically having the same small allocation unit and intermingling sharing both spaces. And the last item that we will do, it's my side project. I want to try if we can get rid of OSD dir when BlueStore is used, just clean up all the metadata files that are in the directory. That will be in pair with just mounting direct. I envision it that it makes sense only if you would be able to mount BlueStore just by pointing to a block device. And all the rest of data will be just imported from device label or superblock or whatever we call it. So far, as I cooperated with Guillaume, it looks like we're on a good footing. It seems like it might work. And also, Guillaume was thinking if we could use a BlueStore metadata storage for Ceph volume. And I guess that's it. That's why I wanted to present as a plan for Tenctacle to achieve. Are there any questions or some I should explain something, expand on some topic?
I have a question about allocators. So from your experience, do people, so I think we default to the hybrid allocator. So in your experience, do people change that? And is there still any usage of the like bitmap allocator or stupid allocator? The reason I ask is um, we have that object store directory under QA directory with I think there is 8 object store snippets in there, and we still test the so the RVD suite in particular picks that up into and mixes those snippets with the jobs. I think I've just checked and we only have hybrid there. We don't have hybrid B-tree, even though it looks like it merged last year. So perhaps that's something to fix. But I was just asking, like, should we be testing hybrid much more and perhaps get rid of those older ones, or do they still matter? What is your kind of feel here?
Okay, so I will answer in a reverse order. B32 did merge last year, but due to some selection code error was not really selectable. You couldn't choose it. Yes, customers sometimes do switch to different allocators, but the last large switch to different allocator I know of was a DigitalOcean switching from hybrid to directly to AVL. For some reason, that hybrid was not had the problems with efficiency, CPU efficiency, and AVL was working for them quite good. For now, I cannot recommend you to switch to any other allocator just because we do not know. We did never provide any testing that would sufficiently be similar to real workloads to test how those allocators behave. We do intend to do it and we'll do it. And then I will get back to you and maybe the defaults will change. So far, I'm thinking that hybrid B32, the new one, is worth testing just because it has that short cache.
Let me add a bit more. So from time to time, I'm recommending some users to switch back to bitmap allocator That's primarily works for not the latest releases, but we know that hybrid allocator had some performance issues with high fragmentation, and bitmap could be a workaround to fix that in some cases. So it's still in use for sometimes. Uh, Other than that, well, currently we hope that hybrid allocator has no issues, but a single one, which is a way it iterates through free list of extents, which is a sort of round robin approach. And this is known to cause some issues with PTL level at some SSD drives, for some models. They are suffering from the lack of information on chunk release. And given the pattern we allocate space, they keep thinking that we use the full disk space. That is a pending PR to try to fix that in every allocator, and also new hybrid B3 2 allocator showed that it could be a remedy for this stuff as well. So in other words, it looks like there is no ideal allocator, and from time to time we use different implementations to do some workaround to fix, so mostly to work around some issues users are facing.
Okay, thanks. And just to correct myself, I think I said that the hybrid B3 allocator was merged last year. It was actually the PR was open last year, but it merged just a few days ago. So no,
Right.
like I shouldn't have asked the question why, but it's still, I think it's still, I don't see, at least not in, like now that I'm looking closer at the PR, there is no snippet added to the QA object store directory, and that's probably the selection issue which Adam talked about. So I'm just just trying to make sure that it gets added there so that it gets a bit more coverage, since that directory is used by other suites. Radius probably does some specialized testing, but the directory is used by other suites, in particular IBD and KRBD as well, to just to vary the allocator essentially at random.
Right. So hybrid B2 allocator is a new shiny implementation, which hopefully fixes. Well, it's up up to the state understanding on how allocators should behave. But on the other hand, it definitely lacks in field experience. It lacks information how it behaves in aged environment, and definitely it might need better QA.
I would like to use that opportunity to maybe ask you guys on maybe some features or problems that you've seen, but somehow were not important enough to raise as a tracker. So, but something that we could have in mind when adding, modifying something in BlueStore. Thank you. Thank you, guys. That's all what I had.
Well, rather maybe some brief discussion on the future of this hybrid between two allocators. So how do we plan to bring it into full-scale production? Right now, it's not enabled by default. So what we need to do that? What do you think?
I guess we will start with adding a new type of allocator for tautology testing. I don't want to declare when testing of allocators against real workloads will be ready, because it's not in a schedule yet, but maybe it's not so important. I guess we could do typical FIO performance testing for performance on both spinners that we have and NVMEs, and just take some time testing on tautology. And if it works and is better, which I expect it will, we will just switch recommendation.
Well, I would like to propose a bit alternative or orthogonal approach, which is maybe marking this implementation as experimental and advising users who are interested in that to try it in the field in a limited scope, which is a couple of SD cores, for example, in a single node. Since otherwise, I doubt we can learn much from tautology testing in terms of aged behavior. So that is how free space degrades over time in long term.
That's true. Hybrid B32 significantly changes reuse patterns, so it will not be even reasonable to provide a switch for already degraded cluster, because we expect it will not degrade that fast.
Right. So it definitely makes sense to apply for a newly deployed SDs. And after that, learn how these SDs behave long term. I mean, we definitely lack testing or any collection, experience collection for other allocators like that. So that's probably a pretty important information we might want to start collecting for allocators, since we up to recently we haven't paid much attention to how these aging problems appear. Or so it was more like it was mostly driven by reporting issues from customers, but maybe we should pay more attention and be proactive in this stuff.
Well, my only proposed approach to this is creation of fast replay tools, something that will not do actual IO, but for purposes of allocating, just behave as regular operation and trash as much real workloads as we have trying to H cluster. That's the only thing I have.
Okay.
Otherwise, we will never be able to ascertain old, existing, or new allocators.
That's true. Yeah, we need some predefined patterns to test against. And this definitely is different from what FIO things like that could provide.
Are there any performance counters that could be useful to capture from existing clusters to determine performance or based on workload, size?
Well, in fact, we added performance counters for locators just recently, and I'm not sure if it gets backported to any real working releases. So yeah, this could be useful if we pay a bit more attention to that in reporting these PRs and reporting these performance counters. And yeah, maybe we might need some more metrics to better understand what's happening in the field. So, in other words, it looks like a good action item as well for future release.
Well, I expect that some byproduct of investigation on RBD patterns from DigitalOcean would be a proposal what performance counters we can actually add to see when we're getting a degraded performance. We could see that some patterns that we previously thought are fairly normal, maybe they only occur when we're running low on small fragments or something like that.
Okay, a bit related topic, but a while ago I submitted a PR which introduced maximum value to track for every performance counters we have. Hasn't been matched yet, but what does upstream think if we really need something like that? I mean, it could be really helpful to identify the bottleneck like we had in hybrid allocator. So with this maximum value could easily show that there is some abnormal behavior and like some allocation takes seconds instead of hundreds of microseconds, and I believe it can be helpful for other troubleshooting things as well.
So Igor, you're talking about promoting, creating some sentinel on perf counters that will promote some out of scope values to health warnings.
Well, this could be a second step, but let's make the first one, which is just track maximum value and print it.
Sure.
So right now we can see average value, but not the maximum one. I mean, without having specific performance counter. So we can instead, we definitely can add for each performance counter, we can add one more counterpart, which is maximum value, but instead we can implement that for every counter which tracks, for example, latencies.
Well, on that topic, I was shown quite recently how unuseful just having average in our counters is. Maybe also that should be addressed. Maybe even few ranges, but some critical counters should have histograms. That's provided if we can make updates of such histograms efficient enough.
Yeah, well, tracking histogram might be a bit more complicated task indeed, and and could have pretty significant overhead indeed. But yeah, in my opinion, tracking just maximum value is a good thing. It should be pretty helpful sometimes. Okay, this could be a bit out of scope for this.
Okay, guys. Any more topics?
Well, if there aren't any BlueStore topics, I see that Sam is here, and I just wanted to bring up kind of a pet peeve of mine is the support for sparse reads on erasure coded pools. I don't think this is. I don't think the problem is like, you know, in BlueStore as just an implementation of the object store interface, but I was wondering if we could like map out what would it take in terms of, because this is obviously, you know, it's much more involved than on replicated pools, since you know, the information is simply not present on the USD that is supposed to serve the sparse read. So this is probably a question kind of more for Sam than for you, Adam. Like, what would it take, and is it something that we can potentially, you know, tie into any BlueStore work, or perhaps into the? It would make more sense to tie this with the improvements that Bill Scales and his team are planning with regards to changing how, you know, reads work, partial reads, etc. maybe something related to the object info T.
So it's definitely an OSD level thing. Plausibly, we could use something at the BlueStore level to do part of it, but that's not going to be most of the work. I'm sorry, I haven't really mapped this out. It's a good question for Bill Scales' team, though. Yeah, I'm sorry, Elliot. This just hasn't been on my radar.
Okay, I'll bring it up like in that forum then. I've been meaning to add a comment to Bill's doc, or it's PR now, to add that to get that tracked, and I just wanted to to have a confirmation that this is an OSD level thing, which I pretty much knew, but still wanted that to be confirmed. So this would be like a change to the object info T and how it works, and somehow have it store this information.
I mean, I guess, but that's not necessarily a great idea. That's potentially 1,000 entries if you want to keep something at 4K granularity for RBD, and that's big. That will have real performance ramifications.
Yeah.
So I am not sure. It could be something as simple as we simply translate the sparse map from BlueStore out into one for the whole object and make an assumption that if something isn't written to one of the OSDs, it doesn't write to any of the others either. But that probably won't be true with Bill Scales' changes, with that team's changes. So I'm not sure. It's deeply related to the way they plan on changing rights.
Okay.
Does that make sense?
Yeah, I think we'll need to. Yeah, I'll leave a comment on that PR just to kind of start the discussion, and also try to bring it up in tomorrow's meeting for kind of general OSD or general core. That might be better for.
Do you have a summary written up somewhere of what you actually need from it? Because
I
the
need
normal...
the sparse read to work the same way as it works for replicated pools on erasure coded pools. I need it to.
False positives aren't acceptable at 4K granularity?
Yes. So it needs to, if the area hasn't been written to, like if a 4K block hasn't been written to, it needs to return that it hasn't been written to instead of returning zeros.
Yeah, the problem is I don't even think the replicated pool was written to guarantee that. That just happens to be how it behaves.
Yeah, and that's something that I brought up with Ceph team when Jeff Layden was working on FScript, and RBD now has built-in encryption as well.
Yeah. I mean, I understand why it's needed.
We now have two components that rely on it working the way it works.
I know, Ellie. I'm just expressing that, like.
Yeah. So you are basically interested in compressing zeros, right?
No, we are
that's
interested
not the problem.
in precisely tracking which blocks have been written to and which blocks haven't. And by block here, I mean an arbitrary range within an object. Well, not an arbitrary 4K granularity. Well, technically, LUX1 actually needs 512 byte granularity, but we previously discussed with Sam that CStore is probably only going to track this at 4K granularity. BlueStore is actually tracking this like at byte granularity, so BlueStore could do whatever, but like BlueStore could also handle the single, like the 512 byte sector. But with CStore and just in general going forward with people hopefully switching to LUX2, and FScript also needing only 4 kilobytes here, I think we should settle on a 4 kilobyte kind of block size.
Okay, I see. What do you? Let me just drill around the intention. What RBD is going to do with this information? This piece,
we need
it's that they're doing encryption. Right, it's that they're doing encryption on a 4K granularity. So if they perform a 4K read, they need to know whether they actually wrote that 4K or not. If they did write it, then they need to decrypt it. If they didn't write it, then they know it's zeros. So it's not the usual read optimization that sparse read is for. This is conservative in both directions.
I see.
Yeah, this
so
is
it's unfortunately
really
much more powerful. And there's no guarantee that erasure coding's configuration would cause erasure coding's chunk sizes to align to that, which is problematic. That means it may not be trackable at the object store level, and we're going to have to add metadata to the OSD to do this. It's a little bit complicated. I guess it's like 1,000 bits. If we want to just use a bitmap, that's probably plausible.
Well, the object size, I mean, it's for the default
For a 4
object
megabyte
size.
object,
Yeah,
obviously.
but the object size RBD actually supports objects up to 32 megabytes, and I think Ceph
I know, but
because it's the same layout structure. So
the metadata ratio would be the same way either way. So
Yeah,
I just usually use a 4 meg
yeah.
object in my head.
Yep.
I don't know. That's big.
But just
have
in
to think
terms
about
of just in terms of so like what would happen if you like if we don't have this is we read from an unallocated area, an area that we haven't written to, zeros are returned by the OSD, and then we run those zeros through the decryption engine and get return garbage to the user, which is like for a block device, one could argue that it is acceptable because like you're not supposed to read from unallocated areas. But then there are all sorts of like standards, like NVMe standard in particular, and like other things, other places where people pretty much rely on reading zeros from like if something isn't allocated or previously was explicitly discarded and the discard was confirmed to be successful. They rely on being able to get back zeros. So for a block device like for RBD, this is a slightly, like I said, there are all these standards and cases where it's nice to have, but it's we could possibly live without it. For CephFS, FS script, since this is a file and it's governed by POSIX, you are required by POSIX to return zeros from an unallocated area, and there the story is the same. Like if the file, like they have a file that maps to objects, and if an area in the object hasn't been written to, it must return zeros. And that's the assumption.
If we just said it's 4K granularity, would that be good enough for the relevant users, or do we need granularity?
Yeah, no, okay. 4K. Like I said, it's.
I don't think there's any way around this. We have to add an additional field to the object info with a bit for each 4K region. It will probably be a pool config, whether it's maintained or not. That way, we don't unnecessarily impact other users. It'll have to be something like that. I don't think we have a choice. I don't think there's any way to offload this to the object store. I
think that would work. Like I said, there is like today, as of today, RBD actually has a requirement for 512 bytes, but hopefully that's going to go away, because time, as time passes. And since EFOScript has a requirement only for single page for 4 kilobytes, I think we should, settling on 4 kilobytes provides a better metadata ratio. The one that you have in mind with 1,000 bits. And serves LUX2 for RBD just fine. So I think that's good enough.
Completion, you guys track clone granularity at an object level, right? So effectively at 4 megabytes or 32 megabytes or whatever, you don't track individual mutations within those objects?
When you
promote objects for RBD clones, it's at a whole object granularity, right?
It's at a whole object granularity level, but we do support something that's called sparse copy up, which is again based on sparse read. So if something is not allocated in the parent, we
I understand, but the RBD doesn't maintain a bitmap with a finer granularity than an object. It relies on the OSD for that.
Yeah.
Okay.
And so right now, again, since sparse read is working as an optimization, if you want to, if you don't want to discount erasure coded pools, then you basically have to contend with it being just an optimization. And so it's fine for the case of pulling something from the parent for the copy operation, because there the difference is just whether we've allocated a bunch of space.
Yeah, I understand. I was just asking whether you're already maintaining a bitmap, and you're not.
Yeah,
not at the relevant
we're not. Yeah, and that's really not tractable at the RBD, because there are all sorts of races that you then need to deal with.
Ilya, you mentioned that this is required for POSIX. Do you know how other distributed file systems are dealing with this?
CephFS is the only distributed file system that supports EFOScript. And it's really the third file system in the world, the first one being ext4 and the second F2FS, which is for mobile devices mostly.
Yeah, Mark, it's
Okay.
not POSIX in general. It's POSIX with FScript.
Okay. Okay.
Because we need to be
Yeah.
able to answer the question, did I write this already?
Yeah.
In
Exactly.
any other
exactly.
case, it's okay for it to be lossy.
Yeah,
Yeah.
because zeros are returned, and then returning zeros to the user is fine. But with FScript, it starts like with this sort of encryption in the mix, whether it's FScript or LUKS, it's a problem.
Yeah. Okay. Interesting. You
Okay.
mentioned exe4 and something else. I didn't quite catch it. What was the other one besides Cephfs?
F2FS.
F2FS. Okay. Interesting.
Okay, let's bring this topic to the tomorrow's core CDS part.
All right, I'll be there.
Good. As we are about the time, thank you, everyone. Let's see tomorrow.
Thank you. Bye.
Thanks.